So till this last video, we have done almost 60% of the periodic table, but this 40% of periodic table topics are also very important. That 60% was important to understand this 40%, and this 40% is very important for the competition exam. In the last we did the atomic radius. Now we will do the ionization energy. Ionization energy is also called the ionization potential or ionization gain enthalpy, also called as ionization potential, or ionization gain enthalpy. Gain enthalpy. Whenever they will say ionization potential, they will give the ionization potential in electron volts, because this is a potential where the atom will release one electron, outermost electron, from its outermost orbit. And whenever they are saying ionization energy, that energy they will write in kilojoule or in joules. So now definition. Now we are coming to the definition. Definition for ionization energy is the minimum amount of energy required to remove an electron from an isolated gaseous atom. The minimum amount of energy required to remove an electron from an isolated gaseous atom. Here, this gaseous, isolated gaseous is very important term. Sometimes when you have an atom, but that atom or element is in the solid form, so to take the electron from it, first we have to make that element be in the gaseous state. For that also, that element will require some energy, but that energy is not we count as a ionization energy. After this, that element is in the gaseous state, then after that, when we are applying extra energy to take out the electron, that energy is called the ionization energy. So from a gaseous atom, you are taking the electron or removing the electron. For example, suppose you have this is a nucleus, protons will be there and neutrons, and these are the orbit of an atom. So this is the second orbit, and these are electrons. In first orbit 2 electrons, then in second orbit 8 electrons. So this is a, if all the electrons are filled in the second orbit also, there's total 10 electrons, so that this is a neon atom. If we remove one electron, then it will be fluorine atom. Now if this atom is in gaseous state and we want to remove one electron, any of this one electron, for that we have to give some energy to this atom so that it will remove one electron from its outermost orbit. That energy is called ionization energy. And this ionization energy is always endothermic process, because it will always require the energy. It will not release the energy. Ionization energy is always endothermic. This is an important point, because this concept, we will see the difference between electron affinity concept also. Now, what is successive ionization energy? Question is, what is successive ionization energy? Successive ionization energy. Ionization energy, we know that the amount of energy required to remove an electron from its outermost orbit from an element, that is called the ionization energy. So suppose you have a gaseous element, you are giving the ionization energy, that we will write IE1. It will form the cation, gaseous cation, and then one electron will come out. This is called the first IE, IE1, first ionization energy. Then if you are giving more energy to this cation, it will give one more electron and will form M+2 gaseous, and one more electron will come out. This is second IE. Then again, if you have M+2 gaseous and you are applying more ionization energy, again it will give one more electron, and that will be called third IE, third ionization energy. So this is a successive ionization energy or successive ionization. First you are removing one electron, then second, then third. 3 electrons you are removing. Now the point is here IE3, IE2, IEN, IE1. Which will be the more, which will be the less, which will be the medium? The IE third ionization energy always will be more than second ionization and first ionization. And second ionization energy will always be, for every atom it is, every element it is true. Now we will see what are the factors which are affecting the ionization energy. Factors, in factor first we will see as is size. As the size is decreasing, for IE3 it was highest, then IE2, IE1. This was the order of successive ionization energies. So we know after removing 2 electrons, IE2, after taking 2 electrons, you are going to remove one more electron. To that, to get that, you have to give some energy to that cation. That energy is called the ionization energy, IE3. And as you are removing 2 electrons, the size of cation will be smaller compared to the size of after removing 1 electron. So size is decreasing after every ionization, so the attraction is increasing, and outer electron becomes more closer to the nucleus. Becomes closer to nucleus, so the attraction of the nucleus on outer electron will increase. Attraction of nucleus on outer electrons will increase. As the attraction will increase, ionization energy will increase. For that, we'll draw a diagram to understand it better. This will be the distance of this electron, and this will be the distance of this electron from the nucleus, d1, d2. So d1 is more than d2, so the IE for d1 will be less than IE for d2. Factors affecting ionization energy. First factor is Z effective. We know that the Z effective is responsible for the attraction of electron towards nucleus. So the Z effective, as it will increase, ionization energy will increase. Ionization energy will be directly proportional to Z effective. Second factor, half filled, full filled subshells are more stable than the partial filled. So it's difficult to remove electron from it. When you have a element or atom that is fully filled or half filled, to remove one electron from that element, it will be difficult. So the ionization energy required for that element will be more. And fully filled subshells, when subshells are half filled or fully filled, are more stable than partially filled. So it's difficult to remove electron from it. This is the very important point, because when we will solve the last year problems, this concept will come in questions. So this concept we have to remember always, because this concept will affect the order of ionization energy. Third, S will need more ionization energy than P, then D, and then F. S orbital is more near to the nucleus, or SPDF order of subshells to nucleus is this. So the ionization energy order will be the same, because S is more near to the nucleus. S will require more energy for the ionization, then P, then D, then F, i.e. order for subshells. Now in period, in period, Z effective, we know that in period it increases, size will decrease, and then because of the size, ionization energy will increase. Size is decreasing, it will need more ionization energy to remove one electron. In group, Z effective is always almost equal or less. In a group, for all the elements, Z effective is almost equal or less, but the size is always increasing. As the size is increasing, ionization energy will decrease, because it is very easy to remove the electron from big size atom. For first period, if you see hydrogen period, first hydrogen and helium two elements are there in first period, and helium is fully filled, hydrogen is half. But fully filled is more stable than the half filled, so helium will require more ionization energy than hydrogen. Okay, and then in the second period, second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and then neon. Neon is fully filled, we know. Then half filled, nitrogen, and when we know that the from left to right, Z effective is increasing, size is decreasing, ionization energy will increase because the size is decreasing. Now here neon is fully filled also, and it's the leftmost atom. So neon will be having the highest ionization energy. Then fluorine. Then in comparison to oxygen and nitrogen, nitrogen is half filled. So nitrogen will need more ionization energy. Then oxygen. Then carbon. Then compared to beryllium and boron, the order should be boron more, beryllium less. But because the beryllium's S subshell is fully filled, beryllium will need more ionization energy. Then boron, and then last lithium. So this is the order of first ionization energy. For third period, order will be highest inert gas in the period is argon, that will be most highest ionization energy, then chlorine, then phosphorus, then sulfur, because phosphorus P subshell is half filled, then sulfur, then silicon, then magnesium, then aluminium, then sodium. Magnesium needs more ionization energy than aluminium because magnesium's S subshell is fully filled. We'll write the here S subshell fully filled. Here this, because of the S subshell it's happening here, and because of P subshell half filled. Now in groups we will see from group 1 to group 18, we will see one and group 2 elements hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Top to the bottom, size is increasing, so the ionization energy will decrease. Order will be, this is the least, this will be the even order. For group 2, beryllium, magnesium, calcium, strontium, barium, radium, order will be the same. Down to the group, ionization energy will decrease. P block elements, group 13, this is the order in periodic table of top to bottom, but for the ionization energy order will be boron will have the highest, then thallium, then gallium, then aluminum, then indium. Indium is having the least. This is exception that thallium is having the highest compared to the gallium, aluminum and indium. Reasons for this you can think like lanthanide, actinide contraction, DD contraction. Because of DD contraction it's changed. And group 14, this is the periodic table order for this group, but ionization energy order will be this. Here it's changing because of the lanthanide contraction. For group 3, 4, 5, 6, this is the order of ionization energy. Group 3, 3D will have highest, then 4D element, then 5D. Group 4, 5, 6 and 10 elements order will have 5D will have highest, then 4D, then 3D, and group 7, 8, 9, 11 and 12 order will be 5D, then 3D, then 4D. So this will be the order for group D elements. From this, if you remember, you can know the ionization energy order for D block elements. These concepts, when you are applying to the questions, it will be easy to understand the concept. If you remember these concepts, it is difficult, but if you know this concept, how it's changing because of the half filled, fully filled, lanthanide contraction or DD contraction, you can do it better. So ionization energy orders, we complete it here. Electron affinity, that we will see in the next video. Thank you.